So lecture 39. So we'll be doing problems on evaluating the polar integrals. Right? And exercises 13.3. So I'm directly starting from the exercise so that you can understand different types of questions. Right? So first of all, we need to convert the given integral into the corresponding polar form, and then we'll evaluate that integral, right? So this is your question number 1, right? So we need to construct the polar integral corresponding to this part, -1 to 1, 0 to 1 minus x square dy dx. So now can you think of this region? What kind of region it is? See, x is varying from -1 to 1, y is varying from 0 to root 1 minus x square. Can anybody tell me? So let's try to understand this. So we have from here, we have root y is equal to root of 1 minus x square. So if you solve a bit, and then you will come to know that this is nothing but the equation of a circle, right? So now if you plot that region, so you know that it's a circle, but why we are plotting this, that you will know. So this is your circle and its equation is x square plus y square is equal to 1. So x is lying between -1 to 1, right? Yes.
Yes, sir.
Yes. And y is lying between from where to where?
-1 to 1.
0 to circle.
That is given in the question. But anyways, if you want to, let's say you want to construct the values of y in terms of x, then you simply say that y running from root 1 minus x square minus 2 plus. Yes, is it right?
Yes, sir.
If I'm talking about the complete circle, right? The complete circle. Otherwise, let's say complete disk rather than saying the circle. Okay. Otherwise, if you see here, your x is varying from -1 to 1 and your y is varying from 0 to root 1 minus x square. So that means we are actually having the semi-disk rather than the complete disk. Yes?
Yes, sir.
Yes, sir.
Okay. Why? Because your x is lying between -1 and 1 and your y starts from 0 rather than starting from the minus root of 1 minus x square. Is it okay? So that's why we are excluding the lower part of this disk. Okay. So now, can you imagine what kind of polar thing it will become? If we'll turn it into a polar form, then how you can write it? So if you think of this disk and you want to cover this disk, in terms of polar coordinates, so your r is lying from, tell me.
0 से 1.
0 से 1, right? And your theta is varying from
0 to pi.
0 to pi, yes. So your corresponding polar form will be theta lying from 0 to pi and r lying from 0 to 1. And your dx dy will get changed into r dr d theta, right? So we have learned in the last lecture why this r will come into the picture. Okay?
Yes, sir.
Okay. So now, the solving this thing is, it's very easy. So first you integrate with respect to r. So you'll get r square by 2, 0 to 1 and 0 to pi d theta. So this will be half 0 to pi d theta. So this will become what? Pi by 2. Right? So you know that this is nothing but if you see the expression, we have only 1 here. So that means this is the area of the region. That area would be what? Pi r square by 2. And r is 1. So that's why answer should be pi by 2. Is it fine?
Yes, sir.
Okay, so let's say this is question number 2. So I'll leave the hint. Yes, so this is x lying from -1 to 1, and your y lies from 1 minus x square negative to 1 minus x square positive. Right? Yes. Can anybody tell me which kind of reason it is?
Sir, full.
That's it. So you're done. So hint would be what? Theta lying from 0 to 2 pi. And r lies from where to where?
0 to 1.
0 to 1.
Yes, yes. So this is question number 5. So this is x lying from minus a to a, and y lies from minus root a square minus x square to root a square minus x square, and dy dx. So can you tell me the corresponding polar form? Is it a circle?
Yes, sir.
Yes, sir.
So your region is a circle, but the only difference is
R.
yes. So your
Radius.
r here, your r running from
0 to a.
0 to a.
0 to A.
so you'll say that your r runs from 0 to a, and since it's a complete circle, so your theta will run from 0 to
2 pi.
2 pi, and similarly your dy dx will get changed into r dr d theta. Is it okay? Yes.
Yes, sir.
Yes, sir.
Okay, so it's fine. So can you do it?
Yes, sir.
Okay, so let's come to the next part. So next is question number 6. So that is your x, your y lies from 0 to 2, and your x runs from 0 to 4 minus y square root x square plus y square dx dy. Now this is slightly different, right? Right? So can you tell me the reason is having a circle, right? Having radius what?
2.
2.
So you know that your r is 2, right? And from here, your y is running from 0 to 2. So actually your y is running from minus 2 to 2. If you see the maximum and the minimum stretch, because your first limit is constant, right? So first limit is get identified by maximum and the minimum stretch. So if you see the minimum stretch is minus 2 and the maximum one is 2, but the given limit of y is from 0 to 2. So that's why you'll start y from the origin, right? Or from the x-axis. And your x is running from 0 to 4 minus y square. So let's say if your y is constant, it's running from minimum to the maximum stretch, then how you get the value of x? You simply put a horizontal line into the region. Okay?
Yes, sir.
So if you put a horizontal line into the region, so can you think of that what kind of x you will get? Ranges of x. What kind of x you can get?
0 2.
Yes, tell me.
0
रीजन अगर देखें तो यहां से यहां तक शुरू हो रहा है ना, लेकिन हमें तो ऊपर वाला चाहिए, है ना? So let's say I put this line over here. So can you tell me x is running from where to where? In this complete region. If I
-2 to 2.
Minus 2 to 2.
No. From here to here, it's not minus 2 to 2.
Sir,
0 to 2.
from minus
minus root 4 minus y square
Yes.
to
It is
root 4
dependent upon x. It's not fixed, right? Yes, you are with me?
Yes, sir.
Yes, sir.
Yes, sir.
Every time when it enters the region and every time when it leaves the region, right? So you think of this circle and it is entering from here and leaving at here. So of course, the values of x lying between root of 4 minus y square to plus root of 4 minus y square. But we are given that it should start from 0 and should leave at root of 4 minus y square. So what does that mean?
Sir, first
Yes.
quadrant wala part.
Yes, only first quadrant, right? So the values of y suggest us that we'll only focus on the upper semicircle, but the values of x further tells us that we should only concentrate on the first quadrant. So this will be our region of consideration in this problem. Yes? Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
So that's it. So now we'll convert into the corresponding polar form. Now you see that here x and y are also inside the expression. So you simply say that put x is equal to r cos theta and y is equal to r sin theta. So your x square plus y square will become what?
R square.
And your dx dy will get replaced by r dr d theta. Always keep in mind, it's a journal mistake that the people leave that transformation. When they do that transformation, then they generally leave that part r and they simply replace dx dy by dr d theta, which is wrong. So now your r lies from where to where? Can anybody tell me?
0 to 2.
0 to 2.
Yes. And your theta lies between?
0 to pi by 2.
2 pi by 2.
That's it. Once you have identified those limits, then it's done, right? So now simply it is 0 to pi by 2 theta, and this here becomes r cube. So r cube would be r4 by 4, and your limits was running from 0 to 2. Now we are only left with d theta. Is it okay? So it is 4, 0 to pi by 2 d theta. So further you can do it, right?
Yes, sir.
Is it okay? Yes, tell me.
Yes, sir.
Yes.
Okay, so let's move to the next question. That is question number 11. Right? So we have 0 to ln2 and 0 to root ln2 square minus y square. Okay? And then e raised to power root of x square plus y square. Dx dy.
Yes,
Okay,
sir.
so can you tell me, is it a semicircle, upper circle, lower circle? Which kind of circle it is?
First quadrant.
Sir, upper circle.
First quadrant.
First quadrant, yes, because both of the limits are starting from 0, right? That ensures that our region will be in the first quadrant only. Okay, so can we draw it? What kind of shape it is? Yes. क्या
Circle.
क्या है ये? Circle है?
Circle.
Circle with radius?
Ln 2.
Ln.
ln2.
तो बिल्कुल इसके जैसा ही, बिल्कुल इसके जैसा ही. 4 will get replaced by ln2. That's it. Right? ln2 square. Right? Is it fine?
Yes, sir.
So we'll write it as, so of course I'll use the same thing. Okay, similar kind of thing. So your r will vary from 0 to ln2, and here your theta will vary from 0 to what? Pi by 2. Okay. E root of r square into r dr d theta. Right? Is it okay?
सर वो r वाला इंटीग्रल अंदर की तरफ आएगा.
Yes, yes. I should replace this. नहीं, एक तो चेंज करना ही पड़ेगा ना. So let's this. Yes, is it okay?
Yes, sir.
Now fine. ठीक है. So this becomes ER R dr d theta. So your theta is lying between 0 to pi by 2, and your r is lying between 0 to ln2. तो अब कैसे कर देंगे?
Sir, pilot.
यस, आगे हो जाएगा ना, इंटीग्रेशन बाय पार्ट्स लगा देंगे. Let's move to the next question, that is question number 30. So that is 0 to 2, 0 to 1 minus x minus 1 whole square, x plus y upon x square plus y square, right? dy dx. So you know that these are the limits of x and these are the limits of y. Yes, right? Asan hai?
Yes, sir.
Okay. Okay. Now this is slightly different. Can you tell me about the limits of this?
सर सर्कल आएगा विद डिस्प्ले सेंटर 1,0 पे सेंटर होगा
Yes,
और
sir.
फर्स्ट
Yes.
क्वाड्रेंट में होगा
Yes,
So
sir.
how, yeah, that's true. That's true. So how we gonna see that? Also, we know that this is starting from the, it is in the first quadrant only. So we know that our theta will be from 0 to pi by 2, right? But what about this? How you calculate the r? How your r will come into the picture?
Will be 2, but starting from 1, 0.
Can anybody tell me?
सर 1,0 से 2 तक जाए.
नहीं नहीं नहीं.
लिमेसन में आना पड़ेगा.
No. Okay. Let me construct this thing for you. This is your y square is equal to 1 minus x minus 1 whole square. Right? Is it okay?
Yes, sir.
So this is your y square 1 minus x square minus 1 minus minus plus 2x. Right? So this 1 and 1 will get cancelled. So x square plus y square minus 2x is equal to 0. Generally do, we put r, x is equal to r cos theta and y is equal to r sin theta. So this becomes r square minus what? 2r cos theta is equal to 0. Yes, you're with me?
Yes, sir.
Here either r0, which cannot be so, or r is equal to 2 cos theta. Right. So now this time our limit will become r is equal to 0 to 2 cos theta. Right. And here, if you put the values of x and y, so this is r cos theta plus sin theta. And you are left with only r square, since cos square plus sin square will be 1. Okay. And dy dx will get changed into r dr d theta. So this r square will get cancelled. Right? So can you see a difference between the previous question and the question which we are doing right now? Anybody? Can you point out those differences? See, we have done the question number 11, we have done the question number 6. Can anybody tell me why question number 13 is different?
सर r थीटा में
r में सर एंगल आ गया.
r थीटा का
Yes,
फंक्शन.
because r theta का function आ गया. That is the thing which we want to say. Okay, so how it makes a difference? Let's say geometrically. So, okay, so in that way, this and this, right? ऐसा ही है. This is 1 0. यही सर्कल है.
yes sir.
Right? Okay. So here your theta is lying from 0 to pi by 2. Now, can you see that? What is r? Can anybody tell me what is r?
2 cos theta. नहीं.
नहीं, वो ठीक है. But r होता क्या? Origin से distance होता है ना?
Yes, sir.
Now, can you see that this theta is moving from कहाँ से कहाँ तक? 0 से
pi by 2.
pi by 2. हाँ, but your r is changing. Change हो रहा है ना r? r क्या ये distance है? Okay, तो ये कहाँ से कहाँ तक जा रहा है?
0 से 2.
0 से 2.
Exactly. समझ आ रही है ना ये चीज? 2 cos theta. See, if you see those Rs are keep on changing. This length is different from this length, and this length is further different, right? Is it okay?
Yes,
Are
sir.
you with me? But here, now, if you keep on rotating those things, even then your R will be same. है ना? समझ आ गई ये चीज? हर जगह R 2 ही है ना इस रीजन में?
Yes, sir.
वहां पे हर जगह R 2 नहीं है. Why? Because it becomes a function of theta. So now, can you solve this integral?
Yes, sir.
Yes, sir.
Okay. So this is our question number 18. Find the area of the region that lies inside the cardioid R is equal to 1 plus cos theta and outside the circle R is equal to 1. Okay. So then I'll prefer to draw the axis. So here and here, right? So since it is your cardioid and it is R is equal to 1 plus cos theta, so as your theta is equal to pi by 2, so your R should be equal to 1. Okay, so it should pass through certain points. This is yes. Now it's fine. Okay, so why this is of this shape? Can anybody tell me? Can you mark the point quickly? Yes.
Sir, 0 pi by 2.
हाँ, यहाँ थीटा 0 रखा, यहाँ है ना, यहाँ एंगल 0 होगा, ठीक है?
Yes,
So if
sir.
you put theta is equal to 0, R would be what? 2.
2.
Right? Fair enough.
Yes, sir.
If you take theta to be pi by 2, so then what will happen?
1. R1.
Yes,
1.
R will be 1. So since the circle radius of the circle is also 1, so they'll meet at this point. Okay. So now, which area is suitable for the problem?
Sir, जो
जो crescent सा बना है.
Yes, sir.
हाँ,
Right, sir.
जो outside the red curve and inside the green curve, यही आना चाहिए ना?
Yes, sir.
Yes, sir.
Yes. You're with me?
Yes, sir.
So this is R is equal to 1 plus cos theta, and the red one is R is equal to 1. Can you tell me R कहाँ से कहाँ तक जा रहा है? Okay.
Sir,
Now,
0.
let me finish with this. जब तुम when you were in a Cartesian system, you tend to drop a line. Either it should be a line which is parallel to the x-axis, or it should be a line which is parallel to the y-axis. So here we do what? We will take R's, different R's, starting from origin and entering into the region, and we'll notice what is the point of entrance and what is the point of exit. Okay, so can you mark the point of entrance and exit? Always starts at
Sir, 1
red curve.
equals to 1.
Yes, and always ends at the green curve.
Yes, sir.
Yes, sir.
Okay, so how much rotation you want? How much rotation you require?
Pi by 2.
We simply say that our region is theta lying from, first of all, theta lying from 0 to pi by 2. And your R lies from, कहाँ से शुरू हो रहा है? 1 से. Starting ही 1 से आ रही है ना?
1 plus cos theta.
और जा कहाँ पे रहा है?
1 plus cos theta.
1 plus cos theta.
Yes, 1 plus cos theta. R is starting from 1 and ending at 1 plus cos theta. Since we want to find out the area, so we'll use 1 over here. Okay. So this question is pretty much important. This would be the crux of whole double integral which you have done. That's why I consider this question pretty much important, so that improves your understanding towards the concept. Evaluate minus infinite to infinite e raised to power minus x square dx. So think of this thing. So consider this thing as I, right? Okay.
Yes, sir.
So I square would be minus infinite to infinite whole square. Yes.
Yes, sir.
So can I write it in this way, that minus infinite e minus x square dx minus infinite to infinite e minus x square dx? Can I write it in this way?
Yes,
Yes,
sir.
you're with me?
Yes, sir.
Yes, sir.
Okay. So further, can I write it in this way, that e minus x square dx minus infinite to infinite e minus y square dy?
Yes, sir.
Why is it so?
Yes, sir. Sir, वो
Dummy variable.
property of
Yeah,
definiter.
yes. So we know that. So now, further, can I write it in this way? This is a product, and can I convert it into the double integral? Can I do it?
Yes, sir.
Can I write it in this way? Minus infinite to infinite, minus infinite to infinite, e raised to power minus x square plus y square, and dy dx or dx dy, doesn't matter because we have constant limits, right? In the sense that the limits are not dependent. Okay. Now, can anybody give me a hint that how to solve this integral?
By using x is equal to r cos theta.
Yes. So put x is equal to r cos theta and y is equal to r sin theta. Now, can anybody tell me what are the limits? Yes, tell me.
R may be minus infinite to infinite.
Okay. And theta?
0 to 2 pi.
Sir, 0 to 2 pi.
जब थीटा 0 to 2 pi ले लिया तो r तो 0 से infinite आया ना?
हाँ सर, 0 से infinite r और 0 से 2 pi theta.
Okay. Think of this line, right? Think of this line, that this line is covering this thing, right? Whole plane. And if you take the stretch to infinite, right? So you want to cover each and everything. So how are you going to do? You will simply rotate from 0 to, tell me, 2 pi. Okay. And your r starts from 0 and runs up to infinity in order to cover that complete plane, right? Why? Because we have x running from minus infinite to infinite, and y also running from minus infinite to infinite. Is it okay?
सर एक बार थीटा वापस बताना.
मैं ये कह रहा हूं कि थीटा को 0 से 2 पाई लेना ना, पूरा प्लेन कवर करना. ये पूरा प्लेन है, इसको कवर करना, तो थीटा पूरा घुमा दोगे ना 0 से 2 पाई तक. ठीक है. और उसके बाद क्या होगा? ये पूरा घुमाने के बाद अब तुम्हें r चाहिए पूरा 0 से इनफाइनाइट. ओके. तो r क्या कर दोगे? तुम बढ़ाते चले जाओगे कि नहीं? समझ आ गई बात?
यस यस यस.
तो अब ये इंटीग्रल क्या बन गया तुम्हारा? r runs from 0 to infinity, okay, and theta runs from कहां से कहां तक? टेल मी. थीटा runs from 0 to 2 pi e minus r square r dr d theta, right? Now how polar helped us? I'll come to that part. But here, if you put r square is equal to t, r dr dt बन जाएगा ना? So I'll only consider this integral first. Consider this integral first. this part first, r. So put r square is equal to t, 2r dr is equal to dt, r dr is equal to dt by 2. So this becomes minus et dt by 2. If your r is 0, your t will also be equal to 0. And if your r is infinite, your t will also be infinite. And what will be the integration of e minus t? E minus t minus 1. Right? And by 2, 0 to infinite. So this becomes minus half e minus t, 0 to infinite, minus half upper limit क्या आ जाएगा? 0. Lower limit minus 1. So becomes what? Half. Is it right? Yes, tell me.
Yes, sir.
Yes, sir.
So now I put simply this thing by half. I will replace this thing. So 0 to 2 pi half d theta. So this becomes what? Pi bana na?
Pi.
Yes, tell me.
Yes, sir.
Pi ban gaya. So now we were saying that therefore our I square is equal to pi. So therefore I is what? Root pi. Okay. So now what I'm trying to say is why we were able to do this question. This is just because of the blessings of this r which appear in this expression. And earlier we had a kind of same expression, but we didn't have this kind of x over here. Otherwise, we could have put x square is equal to t and 2x dx will be dt. Right? Are you getting this?
Yes, sir.
So
Yes,
this r, due to the polar transformation, just came into the picture and helped us in solving this integral. Okay? So that's why sometimes even you need a single integral, even if you want to solve that single integral, you need the help of the double integral. So that's why this tool is pretty much important. And that's why a polar transformation is also equally important. Because just because of polar transformation, we will be able to solve this very easily. Right?
Yes, sir.
So this is the whole crux of the chapter. There are questions which can only be dealt or very efficiently dealt by using polar integral as well as double integral. So that's it for today.